Thanks to its powerful features, this would give us a much fuller picture of the world as we know it now. The best picture ever seen was just taken by the James Webb Telescope. Come with us as we learn more about the James Webb Telescope and how it might make everything different. After the telescope was first suggested in 1996, 3 groups of scientists and engineers from the public and private sectors got together to see if NASA could actually build the telescope. All 3 teams came to the same conclusion: the telescope could be built. In 1997, NASA agreed to pay for more studies to improve the technical and financial needs. By 2002, the agency had chosen teams to build the telescope's most important equipment and an advisory group of scientists to help with the building process. The telescope was officially named the James Webb Space Telescope that same year, to honor the former head of NASA who made important contributions to the growth of the Apollo program. When engineers and scientists started building the Webb telescope in 2004, they had to come up with new technologies and methods to meet the mission's strict science needs. Astronauts could fix and improve Hubble while working from Earth, but Webb would have to do all of its work from too far away for Earth to be able to help. Despite these problems, the team finished all 18 mirror pieces and put them through a lot of tests to make sure they met the standards. It was finally possible to picture the telescope going into space and doing its job. The James Webb Space Telescope was built from 2012 to 2013. Different parts of the telescope were being built in different places around the world. Building started on Webb's sunshield layers in 2013. These layers protect the telescope from too much heat and let it work well in space. Over the next few years, Webb's different science instruments were put through tough tests with high temperatures and shaking. At the same time, the telescope's 18 separate mirrors were carefully put on its backplane frame. All of these parts were put together and tested at NASA's Johnson Space Center in Houston, Texas, in 2017. The telescope and its equipment also went through one last round of environmental tests in a huge thermal vacuum room to make sure they would work properly when put into space. Webb was finally sent into orbit around the Earth on December 25, 2021, at 7:20 a.m. Eastern Standard Time. So, how does the telescope really work? People often make space travel sound too easy, so when you first hear about it, it might sound like just another camera. That's not the case. It's very different, which is why it took so long to get from idea to start day. The James Webb Telescope is a strong infrared telescope made to look at things in space that are too cool or faint for regular telescopes to see. These are things like stars, galaxies, and planets that are just starting to form. The telescope is designed to pick up infrared light, which is what these faraway celestial bodies use to give off most of their heat. This lets us learn more about these things. Infrared light can't get through gas and dust, which makes it look cloudy to our eyes. Webb, on the other hand, can see ultraviolet radiation as well as visible light and infrared radiation. This lets it take pictures of things that are hidden by dust and gas, giving us a better view of things happening far away in the universe. It is also possible to study the features of things on Earth, like their chemical makeup and temperature, using infrared light. So, infrared light is useful in a lot of areas of physics, science, and technology. It can help us learn more about how stars, galaxies, and other cosmic objects are put together and how they change over time. It can also be used to find signs of chemical pollution in our environment. The telescope has a big collection of mirrors, high-tech imaging and spectroscopy tools, and cutting-edge thermal control systems that let it work in harsh environments like space, which, as you already know, is very harsh. Because this camera is meant to go into space by itself, it had to be built so that it could handle anything out there without any help. After the telescope was shot into space and separated from its launch vehicle, it unfolded and started its long trip to its goal, going through a complicated set of steps as it went. There were several important steps in this process, such as going across the moon and breaking up into different pieces. The telescope became one of the most powerful tools of its kind as soon as it was fully set up. Let's take a look at the steps this groundbreaking telescope took to get into space before we talk about why it was so important. The launch was the first thing that had to be done. The solar array was put in place after the launch. 2 special pallets were put out on the 3rd day of the trip while the astronauts were still inside the ship. The important sun shields for Webb were stored on these boxes. These shields keep the telescope cool and allow it to work properly in space. The placement of these shields was very important for making sure that the camera could work well during its journey. On the 4th day, The tower that held the instrument package was moved to its final spot and put together. There were a lot of complicated steps in this process, but it all went smoothly because of how the telescope is built. The momentum flap was then raised. The sun's pressure works on the big sun shield, making a force that keeps the telescope stable. Next was the release of the sunshield membrane cover, which showed the tennis court-sized sunshields. After everything was set up, the sunshield and mid-booms were put in place. The 5 pieces of the sunshield were then pulled apart. But this isn't the end. When the James Webb Telescope was put into space, it had to go through a number of important steps. The second mirror and a frame to keep the smaller mirror in place were put in place on day 10. The main mirror wings were then stretched out on day 13, which made the telescope its full size and shape. After these steps were done, the telescope was ready to start its job of looking at stars and planets far away. What's interesting about the James Webb Telescope is that it wasn't really made to do just one thing. Quite a bit of things should be solved by it. Let's look into this some more. Scientists like Daniel Einstein, an astronomer at the Harvard-Smithsonian Center for Astrophysics, can use telescopes like the James Webb Space Telescope to go back in time and see galaxies when they were just starting to form. Light moves slowly, so a planet that is far away looks older than it really is. The telescope can look at the early history of galaxies to learn more about how they formed and how they changed over time. Because it can see galaxies so far away, scientists like Einstein can get a full picture of how galaxies form and change over time by looking at different galaxies at different stages of growth. Webb is great for studying faraway galaxies because it can see infrared light. The universe is expanding, which makes the light from these galaxies longer over time. This changes the color of light from visible or ultraviolet to infrared. Webb is very good at picking up infrared signals because it is big and cold. This lets it see much farther into space than other telescopes. This makes it possible for it to see galaxies as they grow and change, taking pictures of how they change over time. We can learn more about how galaxies form and grow thanks to Webb. This helps us understand the world better as a whole, putting together what we know. Stars are born from thick clouds of gas and dust that are called stellar nurseries. Because these clouds are so thick, visible light can't get through them. This makes it hard for scientists to use regular binoculars to study these areas. But infrared light can pass through the thick dust clouds, allowing the James Webb Space Telescope to peer into these stellar nurseries and observe the processes that lead to the birth of stars. By studying these regions in detail, scientists can gain insights into the early stages of star formation, including the conditions that trigger the collapse of gas and dust into new stars and the factors that influence the mass, composition, and lifespan of these stars. Webb's ability to see in infrared also makes it an invaluable tool for studying exoplanets, which are planets outside our solar system. These distant worlds often pass in front of their parent stars, causing the starlight to dim slightly, a phenomenon known as a transit. During a transit, some of the starlight passes through the planet's atmosphere, allowing scientists to study the atmosphere's composition. The James Webb Telescope can detect the faint signatures of molecules such as water vapor, carbon dioxide, and methane in these atmospheres, providing clues about the planet's potential habitability. In addition to studying the formation of stars and exoplanets, Webb will also explore the mysteries of dark matter and dark energy, two of the most elusive components of the universe. Dark matter, which makes up about 27% of the universe, doesn't emit, absorb, or reflect light, making it invisible to traditional telescopes. However, its presence can be inferred from its gravitational effects on visible matter, such as stars and galaxies. By observing the distribution and behavior of galaxies and galaxy clusters, Webb will help scientists map the distribution of dark matter in the universe and understand its role in shaping cosmic structures. Dark energy, which accounts for approximately 68% of the universe, is even more mysterious. It is thought to be responsible for the accelerated expansion of the universe, but its exact nature remains unknown. Webb will study distant supernovae, exploding stars, that serve as cosmic yardsticks to measure the rate of expansion. By comparing the observed rate of expansion with theoretical models, scientists hope to gain new insights into the properties of dark energy and its influence on the fate of the universe. Webb's advanced capabilities also extend to studying objects within our own solar system. The telescope can observe the outer planets, their moons, and even distant dwarf planets like Pluto and Eris. By analyzing the light reflected from these objects, Webb can provide detailed information about their surface composition, atmosphere, and weather patterns. This data will enhance our understanding of the solar system's formation and evolution, and may even reveal signs of geological activity or the presence of subsurface oceans on icy moons like Europa and Enceladus. Moreover, the James Webb Telescope will play a crucial role in the search for life beyond Earth. One of its primary objectives is to identify potentially habitable exoplanets, worlds that lie within the habitable zone of their parent stars, where conditions may be just right for liquid water to exist. Webb will analyze the atmospheres of these planets for biosignatures, chemical compounds that could indicate the presence of life. While detecting definitive evidence of extraterrestrial life is a daunting task, Webb's observations will bring us closer to answering the age-old question of whether we are alone in the universe. As the successor to the Hubble Space Telescope, the James Webb Space Telescope represents a monumental leap forward in our ability to explore the cosmos. Its cutting-edge technology and unparalleled sensitivity to infrared light will allow scientists to observe the universe in ways never before possible. From the birth of stars to the detection of distant exoplanets, and from unraveling the mysteries of dark matter and dark energy to searching for signs of life beyond Earth, Webb promises to revolutionize our understanding of the universe and our place within it. In conclusion, the James Webb Space Telescope is not just a scientific instrument. It's a time machine that will take us back to the earliest moments of the universe, a magnifying glass that will reveal the hidden details of cosmic phenomena, and a beacon that will guide us in our search for life beyond our planet. The discoveries it makes in the coming years will shape the future of astronomy and expand the boundaries of human knowledge, answering some of the most profound questions about the nature of the universe and our place in it.